All right, guys, we're about halfway done of this chapter. You guys doing okay? I'm a little tired, but I am enjoying making this video. Okay, if there's something in the video that you like or you don't like, please feel free to let me know so I can adjust, modify, make changes, and these are all just for you. Okay, just always feel free to let me know. All right. I hope you guys doing okay. All right. So we can move further to a kind of new topic, but related to the pKa value still. Okay. All right. We've been seeing the strong acids, a weak acid. For example, hydrochloric acid, that's a strong acid, right? You know that. Acetic acid or vinegar, which is a weak acid. Sulfuric acid down here, you guys know it's a strong acid, and ammonia, that's not an acid at all. That's a weak, very weak acid. Okay, but that's what I told you, right? You've been told. I give you a pKa value, but now I want you to think a little bit further. What really makes this acid strong or weak? Okay, of course they have pKa value that you can look up, but I'm talking about like what actually make them strong or weak. We're gonna get into the detail here. Okay, now the answer to that question is the stability of the conjugate base. All right. Maybe a few years back, you may or may not know this singer. Her name is Megan Trainor. Her debut song is all about the bass, about the bass, about the bass, not acid. She sang that song, right? And yeah, I'm not sure you guys know she has a degree in chemistry and she's great. She's really super smart about it, right? So she said it's all about the base and not the acid. That's what makes acid strong. Here's an explanation to it. Let's take a look here. So I'm going to group them up. So strong acid at the top. If the conjugate base is stable, the acid know, oh, I want to be stable. So they're going to proceed forward, dissociate to become a more stable compound, which is conjugate base. All right. I'll say one more time. If the conjugate base stable, the acid will really want to be a conjugate base because stable. Everyone want to be stable. Right? So hydrochloric acid, sulfuric acid will dissociate 100% and become a conjugate base. Right? That's why we call it strong acid. It doesn't have to think twice, dissociate right away in solution. Right? But now the weak acid, the scenario is reversed. Oh, by the way, so like chloride stable. You guys know sodium chloride, salt. You can see everywhere. We eat it, and in the ocean everywhere. Okay, so that's really stable. But in the case of weak acid, the role is reversed. The conjugate base is not that stable. Right? The conjugate base is not that stable, but actually the acid form are more stable, like vinegar. And you know we not I won't say drink. No, we don't drink. We eat vinegar, put on salad, right? Ammonia that we use in cleaning. These guys are stable enough compared to the conjugate base. Okay, so in this case, the conjugate base say, we're not that stable, so let's produce something more stable. Let's go back to become an acid form. Okay, that's why these guys are weak acids. All right. So my point is, what makes an acid strong is stability of the conjugate base. If the conjugate base stable, the acid would love to become conjugate base, so dissociate 100%. But if the conjugate base is not as stable, the acid will prefer to stay as an acid form. They don't want to dissociate and become unstable. Why would we do that? Doesn't make sense, right? Now, the question is going to be, what makes a conjugate base stable? Okay, there are a few factors. Here we go. Size. The first two we're going to consider atoms. Right? We have size or electronegativity of the atom bearing negative charge. We have resonance effect, inductive effect, and orbital effect. We're going to talk about this. All these factors, we have 5 factors here, will affect the stability of the conjugate base, stabilize the charge on conjugate base. Right? They all have charges here and here. All right, but we don't do this to determine the stability of the acid. So remember what Megan Trainor say? It's all about that base, not acid. Okay, just the base. All right. We're gonna look at this factor one by one. Let's start with the size on the next video.